Hey you guys, in this series of videos I'm going to be graphing a system of inequalities. Now it may be useful for you to look back and just learn how to graph inequalities by themselves. Graphing these lines isn't too bad. It's a matter of knowing which area to shade, which you'll see in just a minute. But essentially we treat these as though they were equal or equalities or equations, and then we graph them and we'll change things as we need to based on what we have, whether it be greater than or less than, and also if it's equal to, we'll change things as well. If we have greater than or less than, then we're going to be using a dashed line. If we have less than or equal to or greater than or equal to, then we will be using a solid line. So notice in these two inequalities, it's both less than and greater than symbols. There's no equal to parts. So for these two lines, we're going to be using dashed lines. So looking back and graphing the equations, hopefully it's helpful for you to see these in slope-intercept form. And you can see slope-intercept form up here in the top right, where slope is the m and the y-intercept is the b. Both of these are in this format, except for now they're inequalities. That's not a big deal. When we graph, we start with the y-intercept, which in this case is, I'm going to graph this one in red, it's 5. So I put a point at 5. Then I use my slope here, 1/2, in order to find the next point, and then continue this pattern. So notice it's a positive 1, that's my rise. Then my run is a positive 2, to the right 2. That gives me my next point. And if I continue this stair-step pattern, then I can see some of the other points that will be on this line, which will be dotted again. Okay, so these are some of the other points on this line, just so you can see these. Okay. Alright, so in connecting the points, I have that line, but again, it is a dashed line. Next equation I'm going to be doing in purple here. So notice my y-intercept is -2, which is right here. My slope is -4/3, so I would go down 4 and then to the right 3 to get my next point. Once again, down 4 to the right 3, but these points aren't close to that red line, so I'm going to have to reverse the slope. Instead of -4/3, I'm going to have a 4/-3. So in other words, I'll go up 4 and to the left 3 right here, and I'll go up 4 and to the left 3 once again. Kind of went a little bit farther, I apologize. Then up 4 and to the left 3 once again. So there are the points. Next thing I need to do is draw the line. And once again, this is a dashed line because it's not equal to, based on the inequality. So here are the two lines, right? So I've gotten rid of all the other stuff, so we can see these pretty clearly. Now this is not a system of equations, so we don't really care about where they intersect, okay? But what we do care is about where we are shading and where the two shaded areas come together. So let's take a look at that. So let's start first with our red inequality right here. And we just need to test a point to see which side of the line we need to shade, okay? So I usually always choose this point, 0, 0, if I can. So in the equation, y is greater than 1/2 times x plus 5. I'm going to replace y with 0 and x with 0 as well, and just see if this is a true statement. If it's true, then I shade that part of the line or that side of the line that the point is on. If it's false, then that side of the line stays unshaded and the other side would be shaded. So let's go ahead and take a look at how that works. Again, if it's true or false, that's what we're looking for here. So is 0 greater than 1/2 times 0 is 0 plus 5. So 0 greater than 5? No, this is false here, okay? So the point that I have here gives us a false statement, okay? So that helps me to see right away that I need a shade on the other side of that red line. So I shaded red like this, and now I need to work with that purple line there. Now notice the purple line does not go through that point either. Okay? So I can use 0, 0 again. And that is what I will do, just to see if it is a true statement. So 0 less than negative 4/3 times 0 is 0 minus 2. So 0 less than negative 2. This again is false. So since this purple point right here is on the right side of the line, kind of, then I know that I would have to shade the other side of that line. Alright, so this is my graph right now, and I need to see which area is shaded by both red and purple there. We can see that it is this area right here that has both the shadings, okay? So that is the only shading that we actually need. So I'm going to get rid of this other shaded parts just so you can see what this should look like without all of the shading, but just where it is, both combined shading. Alright, so what this means now that we have this blue shaded area by itself is that any point in this blue shaded area, and if we were to expand the graph anywhere farther out, all of these would give us a true statement, not only for the red equation, but also for the purple one as well. Okay? It makes this inequality true.